Okay, looking at mixed exercise 6 from the first year core textbook. So we're on circles and we're on question 21, which is a problem solving one. So we've got the equation of a straight line and it meets the coordinate axes at A and B. So it's not too bad to start us off. So I will do a quick sketch. You possibly don't really need one. So minus 3x plus 12. So y-intercept of 12 and a negative gradient. So it can look something like that. So in fact, one of our answers we've already identified. So coordinates of A and B, well, it meets that axis at 12. It meets that axis. Well, the equation of the full line is minus 3x plus 12. So that point there is where y is 0. So we just need to solve that. So 3x equals 12. So x equals 4. So our answer to A, and it does say, yeah, it says coordinates, so be really careful there. So, but it doesn't actually, yeah, it doesn't say which is A and which is B. So, but our answers are going to be 0, 12, and 4, 0. Okay, then we need the midpoints of AB. Okay, so far, so good. So midpoint is just the mean average of these two coordinates. So 0 plus 4 over 2 for our x coordinate, and 12 plus 0 over 2 for our y coordinate. So that will be 2, 6. And the equation of a circle that passes through A, B, and O, where O is the origin. Okay, so that's going to look something like, okay, apologies for this terrible sketch. So it basically needs to go through those 3 points. Hang on, is that right? Place of the circle that passes through A, B, and O. Where is the origin? Okay, well, wait a minute, I can't quite picture what that's going to look like, so we'll come back to that. Okay, so equation of a circle we know is x minus a all squared plus y minus b all squared equals r squared. So we want one that goes through 0, 12, and 4, 0, and 0, 0. So this is going to be solvable because we've got 3 pairs of coordinates to substitute in. So we've got 3 values of x and y. And each time we substitute x and y in, we'll be left with a, b, and r. So we're going to be able to have 3 equations with 3 unknowns. Okay, so if we do 0, 12 first. So if x is 0, minus a all squared is just a squared. And then we'll have 12 minus b all squared equals r squared. I'll square out those brackets shortly if I need to, I probably will. So if I do 4, 0, I will have 4 minus a all squared plus 0 minus b all squared. So that's just going to be minus b all squared, which will be b squared. And then 0, 0, so 0 minus a all squared is just a squared. 0 minus b all squared is just b squared, and that equals r squared. So these are my 3 equations. So 3 equations, 3 unknowns. So we will be able to solve it. It's just easy to get in a bit of a muddle and kind of overcomplicate things a little bit. So I think we'll think about the easiest way of solving it. Okay, so I think how I would do that is, so I think I'm going to have to square out the brackets for the, okay, I'm just going to go for that one purely because 4 is less than 12. This is my only logic there. So if I multiply out the brackets there, I'm going to get 16 minus 8a plus a squared plus b squared equals r squared. And I can say, oh, okay, and actually, yeah, so I have, just from doing that, I've now noticed a nice little shortcut I can take. Because what I really don't want to do is start square rooting things. So I've got those, so the 2 equations I've arrowed, they both equal r squared. So therefore, I can say that they must equal each other. Okay, yeah, if they both equal r squared, they must equal each other. Then I can minus b squared from each side, minus a squared from each side, and everything's looking a lot nicer now because I can then get what a is very easily. Okay, so I got a tiny bit lucky there. It wasn't necessarily obvious how it was going to work out, so you almost just need to sort of start writing things down, but think carefully about each step. Otherwise, you can end up with pages of algebra where you're squaring and then square rooting, and it's all a little bit of a nightmare. Okay, so now we've got a. I want to find b and r. I think I need the full equation of the circle, don't I? Yeah, so I need b and I need r. Okay, so well, I wonder if we could do a similar thing with the top one. So now if I go to the top one, let's make it a little bit smaller so I can get everything on one page. So I'm now looking to this equation because I haven't used this one yet. Okay, so if I multiply out those brackets, that's going to become a squared and then 12 squared minus 2 lots of 12b plus b squared. Yeah, so I can do exactly the same thing in that they both equal r squared. So what I'll do, I'll just move the a squared and b squared together. So I really don't need to do that, but just so it looks the same as the one above. So that equals r squared, but I also know that a squared plus b squared equals r squared. So again, some really handy cancelling. Minus a squared from each side, minus b squared from each side, which just leaves me with 144 minus 24b is 0. So 144 is 24b. So b is 6. And this I think was always the easier equation, so I'm just going to use that. So a squared plus b squared equals r squared. I now know a is 2 and b is 6. So r squared is 40, so we are there. So x minus a all squared plus y minus b all squared equals r squared. There will be, I'm sure, plenty of variations on how you could tackle that. It's a problem-solving one, so there'll be lots of ways we could do it. But as long as this gives us the right answer, we will stick with that one. Fantastic.